Earth may now be entering a region of space that contains debris 3I Atlas released around its perihelion. When a comet approaches the sun, intense heating causes gas and dust to erupt from its surface. Smaller particles, fine dust, are easily pushed away by solar radiation pressure and carried far outward into space. But larger fragments behave differently. Heavier material is less affected by solar radiation and remains dominated by the sun's gravity. Instead of being blown away, these fragments can be pulled inward, drifting closer to the inner solar system. In some cases, their paths can intersect the orbit of Earth. If that happens with 3I Atlas, our planet may now be passing through a sparse field of larger fragments released during the comet's closest approach to the sun. Under normal circumstances, this would simply produce a small number of unusual meteors entering Earth's atmosphere. But there is one detail that raises an interesting question. Fragments released from a comet normally continue traveling at roughly the same velocity as the comet itself. Many would simply continue outward and leave the solar system. Yet some fragments from 3I Atlas might have slowed relative to the comet's trajectory. One possible natural explanation is the presence of complex outgassing jets, sometimes observed as structures that appear almost like an anti-tail, material being pushed in unexpected directions by jets of gas erupting from the comet's surface. Such jets could potentially alter the velocity of ejected fragments, but if someone were attempting to disguise an artificial deployment as a natural comet, this is exactly the kind of mechanism they might use. Every action would need to resemble a known, natural process, even if it looked slightly unusual. A hypothetical deployment system. If an advanced civilization wanted to hide probes within a comet, the simplest strategy might be to use the comet itself as the delivery system. The probes would need to be extremely small, extremely durable, capable of surviving hundreds or thousands of years in space. Imagine objects no larger than a pebble that could fit in the palm of your hand. Inside each pebble could be a dense metallic core protected by a thin outer shell of silica gel and then enveloped by rock, making it indistinguishable from ordinary comet debris. The outer layer would act as camouflage. Nothing about such materials would appear suspicious. Every component could be mistaken for normal comet chemistry. Deployment by the sun. As the comet approaches the sun, solar heating slowly erodes the surface layers of the comet. If objects were embedded just beneath the crust, the sun itself could become the release mechanism. The crust weakens, gas pressure builds, fragments break loose, and the embedded objects are quietly released into space. From Earth, this would look exactly like what astronomers already expect from comets: natural outgassing and fragmentation. No alarms, no obvious signs, just another comet behaving a little strangely. Why haven't we noticed? Even if thousands of pebble-sized objects entered our planet's atmosphere, the event might still pass almost completely unnoticed. Every day, our planet is struck by tons of natural meteoroids. Most burn up high in the atmosphere. Many are never observed. Some produce brief flashes of light, meteors lasting only a few seconds. In other words, the arrival of small objects disguised as meteors would blend perfectly into the constant background of natural cosmic debris, which raises the final question. If a civilization wanted to send something to Earth without being noticed, would they design a massive spacecraft? Or would they hide thousands of tiny probes inside a comet, releasing them slowly as the sun warms its surface? And if that had already happened, would we even realize it? Or would we simply call them meteors?